Welcome to Lab 2. In this lab, we will be observing the motion of an object that is dropped from rest and falls somewhat slowly straight down. First, I captured the video of motion. In this case, we have a cup falling from about shoulder height to the ground. The video was shot in slow motion at 120 frames per second. Next, I analyzed the video in Tracker and extracted the object's position and time. Here's the video in Tracker. As you can see, we have a center of mass for the object starting here. Because the video was quite long, especially at 120 frames per second, to plot every single point of mass. We use this initial data to set our initial velocity in Python to construct a model. We have the range, which is set to 2.7 meters. In Tracker, we see we have a calibration stick. Here, the width of a brick, which is 0.19 meters, and the distance across the video is 2.7 meters. Range is basically the scale of the screen in the model. Here we have the cup and the size of the cup, radius being 0.015 because the size of the cup is 0.1 meters across, so that's half. The mass of the cup here is 0.05 kilograms. Here is the acceleration of gravity and the initial position of our cup. Remember, we started Tracker right here, not at the top. So the initial position is from the top of the video to here. We're subtracting that distance. Here is the initial velocity found by dividing the second frame of height by the second frame of time. This is the final time. The whole video takes about a quarter of a second. Delta T is 1 divided by 120 because this video was shot at 120 frames per second. Here is our code to calculate the F-net force and advance the position of the cup. Let's go ahead and run the model without any drag. As we can see, the cup falls out of the screen because there's no drag. The screen recording cuts it off, but with drag, I see the cup fall and stop. Here is a chart of the observed fall without drag and with drag. You can see without drag, the cup falls almost 1.2 meters, where with drag, the cup will only fall 1 meter. Imagine that the object was initially thrown downward. Would the terminal velocity in this case be the same or different from the case where the object was initially dropped from rest? Justify your answer by using your computer models to examine the object's velocity as a function of time in the case where the object is thrown downward initially instead of dropped from rest. If the object is thrown down initially, we would have a much greater initial velocity, something like this, and we're about to see how far the ball will fall. This we can see is almost a constant velocity because it was thrown so hard, and it went about twice as far. Thanks for watching.